Hello students, in this video we are going to learn CET questions from question number 11 to 20. Read question number 11. 1.8 gram of a compound whose empirical formula is given dissolved in 40 gram of water. So that means solvent is water, solute is an unknown compound. So 1.8 gram of compound means WO2 is given 1.8 gram. So 40 gram of water means mass of solvent WO1, they have given 40 gram. Then it freezes, that means freezing point of the solution is given, that is TF minus 0.465 degrees Celsius, that is a freezing point of solution. Then empirical formula of the solute is given EF. EF means empirical formula CH2O, and they are asking molecular formula. So after knowing empirical formula you can easily find out what molecular formula. So before that we have to calculate molecular mass of the solute. So how to calculate molecular mass of solute? So let us learn that one. So first, by knowing empirical formula you can find out empirical formula mass. So carbon atomic mass 12, hydrogen 2, oxygen 16. So you will get 30, that is empirical formula mass. Now Kf value for solvent is given. Kf for water is 1.86 Kelvin kg per mole. Now since water is the solvent, you know that freezing point of the pure solvent, that is T naught F, that is water, will be 0 degrees Celsius. So these are the given information. Now first you calculate depression in freezing point, delta TF, that is freezing point of solvent minus freezing point of solution. Solvent it is 0 degree minus solution is minus 0.465. So after subtraction you will get 0.465 degrees Celsius, that is delta TF. So now using this relation, that is delta TF is equal to Kf into M. M means molality. You can find out molality. So molality is equal to delta TF by Kf. So delta TF in the above step we have calculated 0.465. Kf is given in the problem itself 1.86. So after simplification, so you will get the molality as M. Small m means molality as 0.25 kg per mole. So that is the molality. Now we are going to use another formula, that is molality is equal to WO2 by M2 into 1000 by W1. So this is the molality formula. Now substitute all these values. Molality we have determined as 0.25. WO2 weight of solute is given 1.8. So molar mass of solute, that is M2, that we have to find out. So into 1000 divided by W1 means mass of solvent, that is 40. So after simplification you will get molar molar mass of solute, that is M2, as 180 gram per mole. 180 gram per mole. So now molar mass of the solute is determined as what? 180. So now you find out N value. So N value is given by the formula molar mass of solute divided by empirical formula mass of the solute. Empirical formula mass of what? Solute. So molar mass of the solute is 180. Empirical formula mass we have calculated, that is 30. So you will get N value as 6. Now you calculate molecular formula. So in first PUC you have studied that molecular formula is equal to empirical formula into N. So empirical formula is given as CH2O in the problem into N is 6. So multiply with 6. So you will get finally the molecular formula as C6H12O6. So it is there in option 4. So therefore question number 11, fourth option is correct. Read question number 12. Phenol associates in benzene. That means phenol is dissolved in benzene. It undergo association. That means solvent is given as benzene. So benzene formula C6H6. So which is dissolved in benzene? Phenol. So that's why solute is phenol. The formula, molecular formula is C6H5OH. So solvent and solute is fixed. Now what is given? So benzene mass, that is mass of the solvent is given W1. So that is 1 kg. So in terms of gram, it is what? 1000 gram. Now coming to mass of phenol, that is solute, they have given 0.02 kg. So if you convert this into gram, so it will be 20 gram. Then molar mass of phenol, that you have to calculate using molecular formula. So that will be 94 gram per mole. Using this, find out molality. So as usually molality formula, so W2 divided by M2 into 1000 divided by W1 in grams. So W2 is 20 gram divided by molar mass of solute, that is phenol, 94 into 1000 divided by mass of solvent is also 1000. So this will be 0.2125 kg per mole. Kg per mole is a unit of molality. Then we are going to use one more formula, that is delta TF is equal to I into Kf into M. So now using this you find out I value, that is Vanta factor. So delta F divided by Kf into M. Now substitute the values here. So delta TF, you read that from problem, its freezing point depressed by 0.69 Kelvin, that is called depression in freezing point, that is delta TF 0.69 divided by Kf means Kf the benzene solvent is given in the problem 5.12 into molality. So we have calculated 0.2125. So you will get Vanta factor as 0.634. Now after finding Vanta factor, so you read that question. So it undergo association, associates in benzene, correct? So for association process, so we use association process, we use the formula Vanta factor is equal to 1 minus of 1 minus 1 by n into alpha. This is the relation between degree of dissociation, that is alpha, with Vanta factor. So now we substitute the values. Vanta factor is 0.634, that should be equal to 1 minus of 1 minus 1 by n. So what is n? So in the problem they have given dimerization. Di means 2. So therefore you take n value as what? 2 into alpha. So from this you can easily find out alpha, that is 0.634 is equal to 1 minus 1 minus half means half. So half alpha means alpha by 2. Then you exchange this. Alpha by 2 is equal to 1 minus 0.634. So this difference will be 0.366. So now alpha is equal to 2 times of 0.366. So this will comes out to be 0.732. So degree of association, that is alpha of phenol in benzene is 0.732. So it is there in option number B, 0.732. So almost nearest value is 0.73. So 12th question, second option is the correct answer. Now coming to question number 13. 0.2 molal aqueous solution. That means molality. Small m means molality is given. Aqueous solution means, so solvent will be water. So weak acid is dissolved in that. So weak acid is HX. The degree of ionization. Degree of ionization means alpha value is given 0.25. The freezing point of the solution. Freezing point of the solution means you have to find out TF will be. So what are all the given things? They have given HX as weak acid. Suppose if HX undergo 100% dissociation, so it gives 1 moles of H plus and 1 moles of X minus. That means totally it produces 2 moles of ions. So it produces how many moles of ions? 2 moles. That's why N value will be 2 for this. Since they're asking ionization, ionization means it is what? Dissociation. Ionization means dissociation. For dissociation process, I value, that is Van 't Hoff factor, can be related with degree of ionization or dissociation with alpha. Degree of ionization or degree of dissociation is called alpha. So they are related using this formula 1 plus n minus 1 into alpha. Now 1 plus n value, you know that is 2 minus 1 into alpha, degree of ionization, that is 0.25. So if you simplify this, so you will get alpha value as 1.25. So Van 't Hoff factor as 1.25. So now use this relation. What is that? Delta TF, depression in freezing point, is equal to Van 't Hoff factor I into Kf into molality M. So substitute that 1.25 Van 't Hoff factor, Kf they have given in the problem 1.86 into molality is also given, that is 0.2 molal. So if you substitute, you will get depression in freezing point delta TF as 0.465 degrees Celsius. So now we are going to use one more formula, that is depression in freezing point. Delta TF is nothing but freezing point of pure solvent T0F minus freezing point of solution. So now they are asking freezing point of the solution. Therefore, we take TF to the left side. So delta TF to the right side. So freezing point of solution TF is equal to T0F minus delta TF. So T0F is nothing but freezing point of pure solvent. Solvent is water. So you know that freezing point of water will be 0 degrees Celsius. In the problem they have not given. So you have to assume minus delta TF. So delta TF means 0.465 degrees Celsius. So it will be minus 0.465 degrees Celsius is the freezing point of solution. So that is a final answer. So it is there in option number D. So therefore question number 13, fourth option is the correct answer. Read question number 14. So which of the following pairs of solution can we expect to be isotonic at same temperature? Remember, isotonic solution means solutions having same osmotic pressure, that is pi, or you can say same product of I and C at a given temperature, at same temperature. So at same temperature, if two solutions have same osmotic pressure, or if two solutions have same Van 't Hoff factor into its concentration, then we can say those solutions are isotonic. So now you read all options. Coming to first option, 0.1 molar urea. That means its concentration is 0.1 into urea means Vanta factor will be 1. So the product of I and C for urea will be 0.1. NaCl is given. So what is the molarity of NaCl they have given? 0.1 into from sodium chloride. You will get two ions, one sodium ion, another one is chloride ion. That means 2 moles of ion. Vanta factor will be 2. So the product will be 0.2. Now these two values are not equal. That's why the first option, in first option the two pair of solutions given are not isotonic. So that is how you have to find out. So if you go on check it, so you will coming to the fourth option. So what is that? 0.1 molar calcium nitrate. For this molarity, that is concentration is 0.1, and what is the Vanta factor? So 1 calcium ion and 2 nitrate ions. So totally we will get 3 moles of ions. So the product will be 0.3. Now what is another pair giving along with that? 0.1 molar sodium sulfate Na2SO4. So what is the concentration? 0.1. How many moles of ions you are going to get from sodium sulfate? 2 moles of sodium ion and 1 mole of sulfate ion, correct? So this will split like this. 2 sodium ion and 1 what? Sulfate ion. So totally you will get 3 moles of ions from this, correct? So 3. So the product will be 0.3. So therefore in fourth option what they have given two pair of solutions, they have same value of I and C, product of I and C. That's why option number 4, they are isotonic with each other. Isotonic means they have same osmotic pressure at given temperature. So 14th question, fourth option is the correct answer. Coming to question number 15, at certain temperature, so they have given 5.12% solution of cane sugar is isotonic with 0.9% solution of unknown solute. What is the molar mass of the solute? So here 5.12% means 5.12 gram of cane sugar dissolved in 100 ml. So 5.12 gram dissolved in what? 100 ml of solution. 0.9% solution of unknown means 0.9 gram dissolved in 100 ml. So what is the molar mass of the solute? So here they have given their isotonic. So isotonic means both have same osmotic pressure at given temperature. So when they are isotonic with each other, when two solutions are isotonic with each other, so you can directly use the formula Vanta factor into mass of that substance by molecular mass of that substance. So here let us take substance 1 is given as cane sugar. Cane sugar means sucrose will be equal to Vanta factor into mass of that substance by molecular mass of that substance, that is unknown solute. Okay, so now you substitute the values. So Vanta factor for sucrose is 1, WO2 mass of cane sugar means sucrose, that is 5.12 gram. Molar mass of cane sugar, you know that, 342. So cane sugar is nothing but sucrose. Formula is what? C12H22O11, correct? C12H22O11, C12H22O11. For this you calculate the molar mass, so that will be 342. So that we have substituted here is equal to, for solute it is unknown solute, that's why Vanta factor is 1. WO2 mass of solute is what? 0.9 divided by molar mass of solute M2, that we have to find out. So finally if you rearrange the things, you will get M2 is equal to 0.9 into 342 divided by 5.12. So if you simplify this, you will get molar mass of solute as 60.1 gram per mole. So correct answer is Nearest value is 60. So option A correct. Question number 15, option A correct. Coming to question number 16, a solution containing 4 gram of PVC polyvinyl chloride in 2 liter of dioxane, that is a solvent, was found to have osmotic pressure, that is pi value is given, temperature is given, what is the molar mass of the polymer. So directly you can write the formula. Molar mass of solute, that is polymer, M2 is equal to Van 't factor, that is I into mass of solute into RT divided by pi into volume in liter they have given. So that's why we are not taking 1000 in the numerator. Now substitute PVC, polyvinyl chloride, it is a polymer. For polymer, Van 't factor is always 1. Then mass of solute, that is 4 gram, that is polymer PVC, into R value. So we have to substitute ourselves because they won't give R value here. They won't give in the question. 0.0821 into temperature is 27 degrees Celsius. After converting into Kelvin, it will be 300 divided by osmotic pressure. So osmotic pressure is given as 3 into 10 power minus 4, and of course volume in liter is given as 2 liter. So after simplification you will get 1.64 into 10 power 5. So that will be the molar mass of the solute, that is PVC. So 1.64 into 10 power 5 is there in option B. So therefore question number 16, second option is the correct answer. Now you read question number 17. So they have given Ki solution, potassium iodide solution, whose concentration is 0.01 molar. Another one is sucrose solution, whose osmotic pressure is given 0.432 and 0.24. 0.432 is the osmotic pressure of Ki solution, and 0.24 is the osmotic pressure of what? Sucrose solution respectively. What is the Van 't factor? So you know that concentration and what? Osmotic pressure, these things are given means, so formula pi is equal to I into CRT. So this is the formula. So now I am going to apply this formula for sucrose first. For sucrose, osmotic pressure is given, pi value 0.24, I value, Van 't factor for sucrose is 1, and concentration for sucrose solution is 0.01, R value, and of course we know that, but temperature is not given, that's why you keep RT as it is. Now you find RT from this. RT will be 0.24 by 0.01, so that will be 24. So from the given data about sucrose, we have to calculate RT value, that is we have calculated 24. Now for potassium iodide, another solution will take for potassium iodide. So we are going to use same formula, that is pi is equal to I into CRT. So Van 't factor that we have to find out for Ki. So osmotic pressure they have given in the problem itself, 0.432 into concentration, of course 0.01, and RT value we have calculated with the help of sucrose, that is 24. So if you rearrange the things, so Van 't factor will be 0.432 divided by 0.01 into 24, so that will be 1.8. So 1.8 is the Van 't factor value. So it is there in option A. So 17th question, option A correct answer. Read question number 80. So they have given 4 different solutions of same concentration, 0.01 molar. So we have to compare their osmotic pressure. So remember, osmotic pressure pi always directly proportional to I into C. So but here concentration is same means, so we can directly equate like this, osmotic pressure directly proportional to I, Van 't factor. Van 't factor means number of moles of ions produced by 1 mole of electrolyte. So coming to option A, so option A, aluminum sulfate. So 2 moles of aluminum, 3 moles of what? Sulfate. So therefore in option A, I value will be 2 plus 3, what is that? 5. For option B, Vanta factor Na3PO4. That means 3 moles of sodium, 1 mole of phosphate. So 1 mole of phosphate. So 3 plus 1, 4. So Vanta factor is 4. Now coming to option C, barium chloride. 1 mole of barium, 2 mole of chlorine. Totally 3 moles. So Vanta factor is 3. So D, option D, glucose they have given. Glucose is a non-electrolyte. It will not dissociate or associate in solution. That's why. So for that, I value is taken as 1. So now for option A, that is aluminum sulfate, they have given osmotic pressure as pi 1. For second one, osmotic pressure is pi 2. Third one, pi 3. Fourth one, pi 4. Since in this case osmotic pressure directly proportional to the number of solute particles, so solute particle is maximum in the case of option A, correct? So therefore pi 1 greater than pi 2 greater than pi 3 greater than pi 4. So this option is there in option number 4. So pi 1 greater than pi 2 greater than pi 3 greater than pi 4. So therefore question number 18, option D, correct answer. So in this problem they are asking percentage by volume of ethyl alcohol. So ethyl alcohol dissolved in water to prepare solution. So what is the total volume of the solution? 454 centimeter cube. So volume of ethyl alcohol is what? 58 centimeter cube. They are asking what is the percentage by volume of ethyl alcohol. So you recall students the formula for volume percentage, that is percentage V by V is nothing but numerator volume of the solute. Solute is C2H5OH ethanol by volume of solution. So total volume of the solution we have to take. Percentage means we have to find out into 100, correct? So volume of the solute ethanol is given as 58 and total volume of the solution is given as 454 into 100. So if you simplify this, so you will get 12.7%, that is a volume percentage of ethyl alcohol in that water. So this option is there in option C. So therefore question number 19, option C is the correct answer. Now coming to the last question of this video, what is the mole fraction of solute? Mole fraction of solute means you have to find out Chi2 in its 2 molal aqueous solution. So what is the meaning of 2 molal aqueous solution? 2 molal aqueous solution means 2 moles of solute dissolved in 1 kg of solvent, correct? So that is dissolved in, since aqueous is given, so water is the solvent. So 2 moles of solute dissolved in 1 kg means 1000 gram of water. So why water is taken as solvent here? Because aqueous solution they have given. So now by this you can say number of moles of solute is 2 mole, correct? So number of moles of solute symbol is N2, so that will be 2 mole. Now the mass of solvent is given 1000 gram means mass of solvent W1 is 1000 gram. So with the help of this you can calculate number of moles of solvent, that is N1. So N1 is given by the formula mass of solvent by molar mass of solvent. So mass of solvent is 1000 gram, molar mass of solvent, that is molar mass of water, that is 18. So if you simplify this, number of moles of solvent will be 1000 by 18 will be 55.55 moles. That is number of moles of solvent. Now the question is, what is the mole fraction of solute? So mole fraction of solute means Chi2 is given by the formula N2 divided by N1 plus N2. So N2 means number of moles of solute, that is 2 mole, divided by N1 is number of moles of solvent 55.55 plus N2 is 2. So after simplification you will get mole fraction of solute as 0.0347. 0.0347 is there in option A. So question number 20, option A is the correct answer.